Hello, and welcome back to the final speedrun of today with me, Vince. So we're going to be going through some inverse trigonometric functions, so let's jump right in. So from the earlier subchapter, you might remember that in order to solve like a trigonometric equation like sine x equals 1/2, we need to take the inverse of both sides, which is the arcsine of sine x. So this would be arcsine times sine x of the sine x is equal to arcsine 1/2. So therefore x is equal to arcsine or sine to the minus 1 of 1/2. So this is actually the inverse function, but the thing is, the inverse functions can only occur if the original function is a one-to-one function. And in this case, sine x is not a one-to-one function, since there are an infinite range of values that it's a many-to-one function. So I mean, because we have an infinite amount of values at each y value. Notice it's still a function, because for each x value there's a unique y value, but for each y value there are multiple x values, so it is not a one-to-one function. And so that's why it's necessary to impose a domain restriction on this inverse function and the original function to obtain a valid inverse function. And normally the domain restriction is negative pi is less than or equal to x is less than or equal to pi. This is the normal domain restriction we put on the normal function, the original function, and this is called the principal value of x. So that's why if you punch it into a calculator, like sine minus 1 of 0.5, you always get 1/2. You always get pi over 6, and not something like 5 pi over 6 or 7, or I guess you could get 13 pi over 6. But that's why you always get this, because in the calculator we define the domain of the original sine function as negative pi is less than or equal to x less than or equal to pi when we're calculating the inverse function. So that it allows us to get an appropriate inverse function. Okay, so let's jump into some questions, and I'll do the even ones. So we need to write down the values of the following angles. First, arctan 1. Arctan 1 over square root 3, and arc cosine 1 over arc cosine 1 over square root 2. And I assume they just mean the principal value, since if we had an infinite domain, these would have an infinite number of values. So, or do they not? Interesting. So they've defined it for, okay, we need to give the values for 0 is less than or equal to x is less than or equal to 2 pi. So first, arctan 1, that's obviously pi over 4 and 5 over 4 pi. These are the two opposite points in the circle, and we know that tan pi over 4 equals 1, and tan pi over 5 over 4 pi is also equal to 1. Next, arctan 1 over square root 3. Well, what values is this? This would be 1/6 pi, or pi over 6. And conversely, 7 pi over 6 would also have 1 over square root 3 as the value, since tan pi over 6 is equal to 1 over square root 3. It's just something you memorize. Finally, we have arc cosine 1 over square root 2. And, well, what would this equal? This would actually equal, if it loads, this would actually equal pi over 4 and 7 pi over 4, since if we take the cosine of pi over 4, which is 45 degrees, we get 1 over root 2, or square root 2 over 2. So yeah, that was pretty simple. On to the next one. We have if arcsine x is equal to 2 pi over 9. Find the exact value of cosine of arc cosine x. Okay. Arc sine x is equal to 2 pi over 9. So x equals sine 2 pi over 9 is what they're saying. Oh, okay. Well, there are multiple values, but what we need to remember is that if we plot these two functions against each other, arc cosine and arc sine, so I mean sine and cosine, if they're saying arc sine x is equal to 2 pi over 9, so in other words, we need to rotate this vertically, or it's sort of saying y is equal to where x on the sine graph is equal to 2 pi over 9. We need to find the equivalent cosine value. So if 2 pi over 9 is, say, here, I'm not too sure how good of an estimate is that. We need to find the y value with the same value. And the closest, oh, that's not one. The closest one would be somewhere like this, which is equal to pi over 2 minus 2 pi over 9. So this is equal to 9 over 18 minus 4 over 18. So this is equal to 5 over 18 pi. Yeah. So 5 over 18 pi, yeah, that's correct. So I guess it's handy to think about it as the cosine value is equal to like something like cosine x is equal to sine pi over 2 minus x. This is something that holds true. And that's, yeah, because of phase shift again. Next, we have, okay. So, bear with my computer. Trying to speed it up. Yep, okay, we have text now. And so we have two functions. F of x is equal to sine 2x. And g of x is equal to 1/2 x. Are defined for 0 is less than or equal to x is less than or equal to pi. So we need to first determine whether the inverse functions exist, and finally the domain is restricted to 0 is less than or x is less than or equal to pi over 2. Find g to the negative 1 of 1/2 and f to the negative 1 of g to the pi over 6. Okay, so first, does the function sine 2x, or the inverse function of sine 2x, exist on the domain 0 is less than or equal to x is less than or equal to pi? No, because if we look at, this is the sine function for those points. This is 0, and remember it intersects back at pi. So to get the inverse function, we can mirror this along the line y equals x, obtaining something like this. And the problem is this no longer passes the vertical line test, because first of all, this is not a one-to-one function in the first place. So this is a many-to-one function since there are many x values for one y value, and so the inverse function cannot exist for this domain. For 1/2 x, of course, though, it does exist. So if we restrict the domain, find g to the negative 1 of 1/2. Well, let's find g to the negative 1 first. This is equal to 2x, and f to the negative 1 is equal to arc sine. Ooh, actually, wait. Sine 2 times x. This would be 1/2 arc sine x, I believe. That would be the correct inverse function. Yeah. So next we need to find g to the negative 1 of 1/2, which is simply 1, and f to the negative 1 of g to the pi over 6. So g to the pi over 6 is equal to 1/2 times pi over 6 is pi over 12, And so we need to find 1/2 arcsine pi over 12. Well, excuse me, 1/2 arcsine pi over 12. Well, what is this going to be? If we go sine -1 pi over 12, I get 0.26 times 0.5, and then we get 0.132 radians. Oh, never mind. It has no real results. That's interesting. Yeah, that's a bit weird. I'm not too sure why it wouldn't exist, but yeah. Maybe it's outside the boundaries of the domain. That could be a problem. Yeah, so that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next